Hold on. There we go. Sorry about that, guys. Yeah, my system rebooted today, so that was that. And it's funny. The unset changes. Cancel. Okay. All right. You guys should be able to hear me now. Yeah. Sorry about that. It's Yeah, that's weird. But all right. So what we're going to do today is a method of learning anything, but I use it for Linux, called the Socratic method, where we just kind of walk through and ask ourselves questions and hop in on the system and see if we understand the things. If we don't understand things, we have to go spend more time with them. But if we do understand them, then we can go. Atticus, yeah, we got the microphone going. Yeah, it was whenever my system reboots, it goes off of this microphone to, I don't even know where it goes, but it doesn't work. So then I just had to turn it on. So that was a good catch. You guys got me. Let me go ahead and pull this up so you guys can see your chat. And then we'll just kind of go through this little Socratic method thing that I like to do with you guys. So the first thing is, I'm on one of my Rocky, so I'm going to get off of Rocky 1. I'm going to go down to like Rocky 5, so I'm nice and out of the way as far as the lab goes. So, what system am I on? Who am I? All of these kind of things. But the first one is, can I list the number of CPUs in the system? Do I know how to do that, right? And I've got a few commands. I can do an ls CPU. That'll give me, that gives me a whole bunch of information. But it probably in there, it shows me that I have 4 CPUs. Okay, so that's good. That gives me a lot of info, though. So maybe I want to say nproc. That's the one that I normally use nowadays. And the way I used to do it before I knew about nproc was cat proc CPU info. This will drop a lot to the screen. But then I used to just grep for proc. And then that would show me I have 4 processors. And then I used to do something like this. And that would give me the same thing as nproc nowadays. So that's the way I used to do it before I knew about nproc. And then this is the way that I do it now. So then you think, like, well, why would I want to know the number of CPUs in the system? Well, I mean, if the system is built the way that I expect it to, maybe I got a call out and somebody says, hey, that system that you guys built for me, that virtual machine that was deployed for my team, seems underpowered. Well, you might go check the big 4, and we talk about the big 4 often. How many CPUs does the thing have, right? What's the speed of the CPUs? Well, we're going to see that here in a second, but what's the speed of it? Well, we should probably know, but maybe it landed on one of our older ESXi clusters and it doesn't, it's not as fast as we expected. There's different things like that could happen. But the point is we can check these things, right? Who knows why we might need to check them? You're going to have all kinds of questions that come in when you're administering and building servers for a company. But one of the main ones is, do I know how many CPUs I have? Another one is maybe when I'm looking at the load of the system, I say uptime here, and I see this load average over here. Well, this load average is relative. Well, first off, it's the 1, the 5, and the 15-minute load against the system. But then you say, well, what's load? Right? Because that's the first question. You would say, well, what's load? Well, load is relative to the number of CPUs you have. If you have 4 CPUs, anything over here lower than 4 is okay on the system. If you start getting higher than that, you tend to end up looking at wait time against CPUs. Now, that's just a general statement. That's not including the fact that sometimes people are hitting 1 core when they should be using multiple cores, and we have ways to go from other things that we've talked about even yesterday to see if you're hitting multiple cores, right? But that's not really the purpose of this right here. So that's not really. I guess we could talk about that. What was that MP stat? Something like this would show. What's that command? It's not MP stat. It's I don't remember what it is. We did it yesterday though. Is it PID stat? Let's go look at PID stat. Yeah, PID stat will show you. So as PID stat is running, if you say, am I actually spanning out across the CPUs or am I hitting the same CPU all the time, we could find that out. And let's say we had some Java process running from one of our devs, we would be able to see if it was actually fanning out across the CPUs or if it was only hitting CPU 0. And then that would be a problem that they'd have to go solve, where they're not parallelizing their code. They're not doing what we call fanning out, right? That kind of stuff. But that's not really that important to us right now. What's really important to us is, can we see the number of processors, right? Because, by the way, a lot of times, guys, you come in and you take over an environment, or you're a new admin and you're trying to figure out what's going on. You don't always have the choice of saying what's you don't always have the choice of building that server out, right? Sometimes you just inherited it. So you're figuring out what's going on. There's poor documentation. There's no documentation, right? So you have to figure out kind of what's going on in the system. All right. So there's that. Can we tell the speed in megahertz of the CPU? So yeah, we can do that. We can say demessage. Demessage. This looks at the ring buffer for the system, grep-i MHZ, and we can see the processor was detected at about 2.4 gigahertz, right? So every 1,000 megahertz is a gigahertz, so 2.4 gigahertz approximately. I can also do ls CPU, and I would probably pipe that through more, and then I would say, okay, here is the speed. We should be able to see the speed here of this processor. Yeah, 2.4 gigahertz right there. So we can find it, right? It's not readily available to us. Like the command doesn't give us exactly that, but we could grep down to it if we needed to. And this shows it in gigahertz, so we might just search that, right, for hertz like that, and then that would find it. And we could also do something like that same cat proc CPU info. Maybe pipe that through more as well, and there's our speed of our processor right there, or also right there the CPU megahertz. All right, so we could find that information very quickly, even if we didn't know what a megahertz was, right? We don't necessarily need to know what that is for when we're figuring out what the speed is. I do think you should go from a little computer science standpoint, figure out what that means if you don't, but that's a good thing. All right, so if you want the quick rundown, each hertz wave, so every oscillation of a sine wave from 180 degree switch is 1 hertz if it happens in 1 second. So if you've got 1 second of time right here and you go like this with a hertz wave, that is 1 hertz. So it's a 1 oscillation of a sine wave is what it is, right? So if it's 2.4 gigahertz, what that means is in 1 second there are 2.4 billion of those sine waves. And you say, well, why does that matter? Well, because the number of ways that you have affects the amount of every cycle like that can be part of an instruction, right? And we have, there's all kinds of things that we can do to shift, to look at how we're sending those things, to send ones and zeros across the line, right? I don't actually know how we do shifts within the CPU. I never bothered to study that. I'm a signal engineer, so I know how we do it over open air and how we do it through like electrical and pulse, but I never bothered to say how we do it through CPU. I can just tell you that's the amount of oscillations of a sine wave over the CPU, right? That kind of stuff. All right, let's see. So can you tell me the manufacturer of the chip? Why is this important? Right? This is very important because we have all these different flags here, and the flags tend to translate over to what we call capabilities, or there's certain instructions that are allowed with these different flags here. So the fact that we know this is an Intel, Xeon Gold, may be something that is not supported. I mean, this is not as old. Some of my other hardware is much older. But those systems have, they may not be supported by newer protocols and things that are coming out. So that's an important thing to see. And a lot of times these flags down here, you'll find, you'll be putting in like a hardware bus adapter and trying to figure out some kind of driver, and the driver won't work unless you have like a certain set of, things there. And you say, well, Scott, could you show me that? Yeah. So let's say we went to, let's just go find, let's just go here. And we go to like, what's the name of that? Driver. Let's go InfiniBand driver. So here's some Linux InfiniBand drivers, right? And InfiniBands are, that's a type of networking that we do, right? And I can go to, let's say I wanted to find a driver for the newest version of Rocky Linux. So let's say Rocky 9.6, that's the most recent supported one. And then the architecture x86-64. And I can go and download all of these different things, but instead I'm gonna go read maybe like the release notes on this, right? So I'm gonna go read the release notes. If anybody wants this, you could, here's the link. I mean, I don't know that anybody would want this, but if you did want it, there's the link. And I come down here and I can read a little bit about it. So here's some supported NIC speeds. So if I have certain network interface cards, in fact, typically with them, you're buying their hardware, so you're going to get their ConnectX 7s, but it'll give you the speeds of things, that kind of stuff. But then typically, here's embedded components, right? That kind of stuff. Typically, if I go and I dig down even a little further, and this is the thing that you do a lot in the engineering space, I'll go find, I need to find their actual doc. And then also you'll see from their release notes the older stuff. Let's go look at their user. It may be in the user manual as well. And let's go to like their installation, hardware and software requirements. Here we go. So platforms, right? Required disk space for installation. We need to get right. These are simple things. But then we keep coming down here, and you need to be root. Let's go look at the OFED. I feel like this is what we were just at. Yeah. Definitely need all those libraries. All right. Go back to user manual. And I thought we had all that. Installation. Downloading drivers. We won't go jumping over there. There's the NIC speeds. All right, well, we already saw all these things. Okay, well, the point is you can go in there and you can dig around to see if it's supported for whatever you need, right? And that's typically, this by the way, this one of my favorite pages to show. I actually show this in the security engineering when we're talking about updating things, because you got to go in and download these, and then you can mount these ISOs, and then you can use those as a repository, and then you can download whatever new versions of OFED information that you need, right? Whether you have the Mellanox ConnectX cards in your system or not, you can practice installing this into the system just for experience. Julius Caesar, you said you finally got into Rocky boxes yesterday. Nice. Yeah, actually, I didn't even check this morning to see who was on, but yeah, we definitely have somebody connected in. So if you guys don't know, I monitor everything, but we have the ability to come in and connect into our Linux boxes, people inside of the Discord. All right. So you know, we're here looking at this, and we're seeing that we can download this kind of stuff. But the main question was, can you tell me the manufacturer of the chip? Yeah, so we can do that. Now the next one is, can you tell me the architecture of the chip? Right. So we can do cat proc CPU info. Whoops, info. Yep. And then we can see the architecture of the chip should be shown in here. Yep, we're a 64-bit chip. And I always have to look for it on here, but it's definitely a 64-bit chip. I can also do LS CPU. That'll also show me that this is a 64-bit, yeah, x86 64. The other ways that we do this is actually uname-m will tell you. So I'm going to drop that right here. Can you tell me the architecture of this chip? Uname-m will also give you that. Hey Leith, how's it going? Hopefully this stuff's useful to you. I appreciate the Prime. I tell you guys all the time, you can use your Primes anywhere. You can use, you can do anything anywhere. But it's always kind of motivating when I get those. So that's kind of cool. Yeah, but can you tell me the architecture of this chip you're looking at? Yeah, and why might you want to know that? Well, I want to know if I'm on an x86 64 or an ARM server. And you might say, well, are there actual ARM servers like those smaller chipsets? Are they actually in data centers? Yeah, they are actually. There's a very famous one that exists out there, and I sometimes show you guys this. If you go to top500.org, this is the top supercomputers in the world, right? And if you guys have never been here, this is kind of a place that... I'll move this up here like this. And if we go look at top 500 right now, that was just published. There's one that's been on the list since the early 2020s, and it's this guy right here, Fukaku. He's down to 7 now, but he's been up there for about 5 years. If we go look at this one, and we go drop in, he's actually using a processor that's an ARM-based processor, right there. That A64FX. And I just remember how big of a deal this was when this one first came out, because he was doing this. And then here's his ranking. Again, he was number one in the world for a long time, back when he first came out. And you might say, Scott, why do you know about this, or why do you pay attention to this? Well, because I build supercomputers. So I build systems. The highest system I've been on this list is 37 and 38 when we built it. But my company's working on one right now that's supposed to be debuting at number one in the world, based on the speeds that we've gotten on it and that kind of stuff. So, and that's working with Dell and NVIDIA on that one. So we kind of got like a little partnership with them. And they've announced that, otherwise I wouldn't say anything about it. But all right, so the point is we can go look at the type of processor, and then that's going to determine, again, that's going to go determine the type of drivers I pick and all kinds of things around the inside of my system. So can I tell the architecture of a chip? Yes, I can. That's at the end of the day, when you're looking at these aren't me challenging you. These aren't these are for you to determine, do I know how to do these things? Can you tell me if this system is physical or virtual? Right? So I'm on a box here, but I could be on a physical machine. I could be on a virtual machine, but how would I know, right? All I know is I SSH into the box. Well, maybe I know the architecture of the environment I'm in. That's possible, but maybe I don't know that, right? So I'm going to come over here and can I tell if it's physical or virtual? LS show. This is LS hardware, and let's see if we can find that out. Now we don't have that command, so we might do DNF what provides ls. Yeah. So list hardware. Yeah, whoops. Install. I normally don't do a -y, not professionally, but inside of a home lab I will. I don't care, right? So now, yeah, here's, oh, look at all this stuff we can figure out. Well, we see that the vendor is QEMU, and that tells us that it is not a physical box, right? We're definitely not on a physical machine right here. So that's good. So the vendor is QEMU. That's a type of virtualization, right? That's a virtualization type inside of Linux, right? I can also do one that is standard, DMI decode -s system manufacturer, and that's QEMU. So there we go. We can try virt what. This probably isn't there. So we might need to DNF install virt what. Virt what is a useful one for seeing if you're virtual or not. So we do virt what, and we see that we're KVM, so we are on a virtual machine. We're not physical. And we can do LSPCI and grep for QEMU. And we see that we are using QEMU for our PCI bridge, so that means we're probably on a virtual machine, right? And we can do systemd detect. This was when somebody showed me at one point, and we see that we're also on a virtual machine. So there's a lot of ways to do that same thing, but suffice it to say, you get called out in the middle of the night and you don't know what server, that's not a set of servers you normally maintain on your Linux team. So you go and you look at the documentation, and maybe the documentation's lacking or not even there. So you land on this virtual machine. It happens to be up, right? It just happens to be up. But now you're trying to figure out, is it a virtual machine? Is it not? You can go very quickly at the command line, see that this is a virtual machine. That lets me know that I need to go into my vCenter or whatever type of virtualization tooling I have to go and try to look at this server and see where it's at. Maybe it's landed on a different ESXi node, or maybe we've been moving off of that. So now we need to go check it for wherever it's supposed to be in the environment. There's all kinds of things that can happen. But as we're kind of running through and figuring things out about systems, sometimes we have to do these commands and just figure out what's there, right? So there's that, right? And then we start to go into, like, can you spin up? So we're talking still mostly CPU stuff, but can I spin up the CPU load on this box and kind of see what's going on? So I'm going to clear the screen up, and let's see if stress is on this box. There's no stress. DNF install stress. And now if EPEL is there, we should be able to install stress. So stress is a tool that will let us, if we just look at it here, it'll let us spin up CPU, disk, memory usage on the box and just see if we can, well, and a lot of times it's just basic stress testing of a box, right? See if we could break something. If you don't break anything during a stress test, all you've done is a load test, right? Load tests are where the system handles the load. Stress tests are where we break something, right? That's always the differentiator between the two. The methods for doing stress and load tests are exactly the same. But if a system handles the load, it's a load test. If it breaks in a certain component during the load test, now you've created a stress test, right? That's the differentiator between them. But it says, can I spin up the CPU load for 3 minutes? And it says, yeah. So I can stress -C4 timeout of 180. And I'm going to put that in the background so I don't have to look at it. And then I might just say, while true, do uptime, sleep 5 done. And we might just sit here for a few seconds and watch the system CPU spin up. We have other ways to watch this as well. We have monitoring and stuff. But now we watch that CPU load average for the 1 minute go up much quicker than the 5 or the 15-minute sliding window, right? So we're seeing that box start to spin up. And you might say, Scott, when does it actually get to high load, right? There's 4 CPUs that we dispatch the hogs for. We know there's 4 CPUs in this box. Well, it's starting to get to high load once this number here goes above 4. As far as, you know, what we typically consider in an operational system, right? So this is spinning up, right? We're seeing that happen. Now, these numbers will keep going up, right? So this number isn't a question of what we call utilization. This number is actually a question of what we call saturation, which is if we're starting to get wait times against the CPU. If this number goes higher than 4, and we have 4 CPUs, then you have the potential for wait time to start to exist on a system. Fun tip I've learned today, you could do while sleep 5 true X done instead of an extra sleep. Yeah, I just sleep inside the loop. Oh, you did while sleep 5. Oh, okay. Yeah. So while sleep 5, as long as it keeps testing to true. Okay. Yeah. I've never tried that before, but that's excellent. So that's a cool little trip. So yeah, because that's going to keep evaluating to true every time it exits. So then it's going to keep doing and then done instead of the extra. Yeah. Okay. That's fair. And by the way, guys, when I show you this, I often talk about how this is terrible computer science. You never create infinite loops in computer science. But in systems administration, you do whatever you want. Now, this should probably be finishing. It's a 3-minute thing. So it should probably be finishing pretty soon here. And then we're going to start to watch this drain back out. So that's kind of cool. Yeah, I never thought to just do while sleep. That's actually pretty smart. So I may start doing that in the future. I'm just an old curmudgeon. So I'll typically do the same command the same way every time. We're going to see that get right up around 4, and then we're going to watch it drop back down here. So speaking of that, we mostly start on this with CPU info, right? So this starts with CPU info. And then we go down into memory topics kind of next after we do this. But we spun the system up a little bit. We see that going up. And then we'll be able to watch it come back down here in a little bit. It'll be... Let's see, it's 180 seconds divided by 5, so it should be 36 iterations of this, so it should be done pretty soon here. There's stress finishing because it was backgrounded. Now we can watch it we'll watch it go back down. We'll watch that overall usage drop back down on our system. And then, yeah. And by the way, I'm on a little early again today because I've got a lot of family stuff to do. So I'm gonna do a little bit of early morning streaming, show you guys around the systems a little bit. We've got a professional Linux users group. You guys are welcome to hang out in there. We're almost to 5,000 members in there. Now, is everybody active? No, but I mean, it's a place where you can kind of go and bounce ideas off of other people that are trying to get into the same field as you. A lot of us are in the field. We've got admins, engineers, architects. We've got just people all over the spectrum. I mean, we got a fair amount of managers in there as well, because some people moved on to management. We got a fair amount of programmers in there too. But the goal is to get you guys doing this stuff professionally. If you like doing this for fun, which if you've watched me for any number of time, or anything more than like 5 minutes of watching me, probably you're interested in Linux. I would say most of you go off and do something else otherwise. So there's that. Are you asking why I use the ampersand? Let me show you. Are you asking? So were you asking why I did the ampersand like that? Is that the question? So what this did? So you've got whenever you run a command in Linux, right? If there's interactive, and then there's basically things that have been told to background, right? Mostly. And there's also daemonizing things, but we're not going to worry about that for here. But when I do command line things, if I had just run this command like this, for 180 seconds, my system would just be sitting at a locked terminal. And my options would be like to Control C to stop it, or Control Z to background it. I think Control Z background. I don't know. I don't really use that. But the point is, I wanted my terminal back so we could look at stuff. So I immediately backgrounded this process like this. So if I do a stress like this, and then I do like a BG here, it'll tell me, or jobs rather, it'll tell me that there's one command running in the background. And then I can foreground that command. I don't do this professionally. I just know this from like labs when I was younger. I can foreground one if I want to bring that back up to the front. But I'll be honest, I don't really use any of those at the command line. And I don't really often background like this. Normally what I do professionally is I just have another shell here down in my screen, and I would just hop both of my nodes into the, like I'd have two connections into the server. I would do whatever thing I was going to do over here, and I would monitor it in the other one. That tends to be the way that I do this stuff professionally. When I show you guys stuff, I'll do little tricks like this, but I'll be honest, I don't really background stuff like this much professionally. I don't like to add two commands that I want them to run a certain way. But this was, by the way, this was the command that was mentioned earlier. We could have just done while sleep 5. This was the command that was mentioned. We could have done this, and this would do the same thing as my other command. Yeah, and every 5 seconds it'll test to true, it'll execute the block of code, it'll come back, it'll wait, it'll test for true again, which will be true, and then it'll run through. So that's kind of that. Yeah, so ampersand is useful. If I might, I'll show you this. So the way I originally used to use ampersand, and this is going to get kind of deep into the weeds, but I'll give you guys a caveat. When we want to connect to a lot of Linux systems at once, right? I'm going to say Ansible. Ansible is my tool nowadays for this. And I'm going to say Rocky, so this will hit all my Rocky servers. And I'm going to say shell, and then I'm going to say a uptime. And it's going to go hit my 5 Rocky boxes real quick and be like, okay, here's the uptime. But before we had Ansible, you say, well, Scott, how did you do that back in the day when you didn't have Ansible? Well, we used to do it more like this. I would go for, let's just say, server in, and then I would count. So I would say a sequence of 1 to 5. Now, you can also just do sequence 5 there, but let's say that is how I did it. And then I would say do SSH to $server. And then I would say uptime on my servers, and then I would say done. And watch, this will go, bam, real quick. Well, if I did it right. For server in that down server uptime. Sequence 1 to 5. Huh. That's weird that's hanging. I must have done something dumb. Oh, why that's hanging. For server, and this is the way we would always do it. Do SSH server, check for uptime real quick, and then done. Oh, well, hold on. It's actually funny. I'm gonna show you this real quick. Let's also add a host name. I think I know what's happening. Host name, and then uptime done. I'm going to remove this, and I'm going to put an ampersand right here. So this goes back to the other question. Actually, this is a perfect thing. I bet that's hanging on the first server. So I'm going to do it like this, and it got through all of them. I'm surprised that didn't come to the screen. What's going on here? Host name, uptime, ampersand done. Yeah. Huh. Well, maybe I'm losing it. But the point is, it went to all of them. Why is that not coming to the screen? It doesn't matter. It doesn't matter why it's not coming to the screen. The point is, that's how we used to do it. And then, well, I got another trick. If that thing is actually hanging, we could do a timeout like 3. And if it doesn't connect, then it's just going to jump over it. I think it's hanging on the first one. I think somebody's doing something in Rocky 1. Maybe that server's blasted right now. I'll be real honest. I don't know why that's not coming to the screen. It's kind of a strange thing. We won't worry about that too much. We won't worry about that too much. But so anyway, so we were looking at this, and now we spun up the system to a higher CPU load, and we used the tool stress. That's what we did a little while ago. We could also just do a sequence of urandom and then bzip it, and that would cause a high load on the system as well. And then we can also do OpenSSL to just test. This is actually kind of fun. This will just spend a bunch of CPU cycles by forking and then running a bunch of OpenSSL with all of the different types of hashes that it has. So it'll just run 4 of them against all the things. And this spins the CPU up pretty high as well. We could watch that spin up if we wanted to. But all it's doing is going through all the different types of hashes it has. So it did the MD5s, now it's doing the SHA-1s. It'll do the SHA-256s here in a second. And it's doing 1 for each processor. Basically testing how fast it can run through all of its hashes, right? Yeah, we're still on SHA-1s. I'm going to stop that real quick. I'm going to do an uptime real quick. And we see that it's spinning up. Yeah, that's super weird that's we're having some kind of something going on in the network. Hold on. Yeah, I don't know. We got something busted in the routing right now in the lab if that's not working, so we can mess with that later. But oh my gosh, dude, hold on. You're right. I'm dumb. Shit. You're right. I was being dumb. I was like, what the heck's going on there? It's too early in the morning for me. You're exactly right. I needed the prefix on it. I can be dumb sometimes. Yeah, there's Rocky. Yeah. So there's the system uptime. But if I wanted to background it, I would just do this. Yeah, I don't know, man. I don't know what I was doing there. Sometimes I'm doing that to test you guys. But so if a system's hanging, this is the way we used to do it. You have no control over that loop. It would just sit there and wait. The timeout will also work, by the way. So here's my timeout. So with the timeout, it would be the same way. Yeah, I don't know what I was thinking. My brain's not working this morning apparently. This would hit all the. Yeah, you're right. I didn't have. I'm so used to having the number already there. Yeah. Well, and you know what? It's actually funny. I haven't had any caffeine in 3 months, so I'm nixed caffeine out of me completely. So that's kind of funny. You say that, but yeah, good catch. I wasn't thinking there. But that's how this is how I used to loop back in the day before Ansible came around. Now with Ansible, you just loop over using Ansible. So you compare that command with something like this, which was super easy to hit all my boxes, right? And then you just say, well, how? And by the way, a lot of times people will look at stuff like this and go, well, I would just script that into a this and this. Sometimes you just use individual commands as ad hoc or one-offs because as an admin, you just want to find information quickly. So I tell people all the time, should you know how to write scripts? Absolutely. Should you know how to turn things into like playbooks and this other stuff? Absolutely. Those are skills that you need to have to repeatedly build systems the same way to be valuable to your team and these other things. But on the other side of it, doing things quickly when somebody like asks you for, hey, do you have all these 10 servers and like their size of their CPU? Yeah, you're not going to go write a big playbook for that. You're just going to write a little one-off command and then you're going to send it back to them in an email, right? So these things are Kankle, it took me a long time to kick that caffeine. Not a long time. Like when I decided to do it, I did. But like the first week of that was terrible. So, yeah. Switched to apple juice for a while. Yeah, Cat Loki, I've mostly been doing just water. I do sugar-free Sprites as well sometimes. The wife will get me those, although they have like a weird taste to them. So I don't know if I'm going to keep drinking those. So. DP said, how do you guys keep up to date with news and vulnerability remediations at an enterprise level like Copperfield? So typically what happens with a company is you're probably going to have dedicated teams in security where those teams are watching for, it's typically what we call GRC, governance, risk, and compliance. And those teams deal with that kind of stuff, right? But hold on, they're not well, they are technical. They're on the security engineering side, but they're not like Linux engineers like we are. They're not people that fix the stuff. So a lot of times they just end up being, and I hate to say it like this, people are gonna get mad if they're in security. They end up just being audit monkeys. And you say, what the heck's an audit monkey? An audit monkey just like, ooh, it just looks at the problem and then tells somebody else to fix it. It doesn't really actually do anything. Well, so since most companies aren't big enough to have an audit team that's doing all that work themselves, what happens is you're paying a third party. So the big third parties in that space are Qualys, Tenable. Tenable is they've got, so Qualys has the Qualys scanner. Tenable has the Nessus scanner. And what they do is they walk through your environment, typically as like an admin service account, and they just check all of the types of stuff in your system. So on a box like this, they might go here and they might say RPM-QA, and there will be all kinds of these in your logs if you ever use one of these tools. RPM-QA open SSH, right? And then they'll just make sure that a few things, they'll make sure that they're the same across your environment. So they're looking for things that are outside of your normal compliance. Like we patched all the servers last weekend in the dev environment, therefore these should be updated. Why are one of these not updated the way that they should? That's one thing. The other thing that kind of happens is, nope, you're not going to be in the business of knowing all the vulnerabilities that are out there. The place that you find all the vulnerabilities that are out there in the world are the NIST CVE database, right? This is where published vulnerabilities are at. Well, most of us are not going to be in the business of writing an API crawler that goes and crawls this, right? Most of us aren't going to keep track of that and compare it. So that's what you're paying these third parties for, and that's what they do. So the question was like where how you keep track of these kind of things. And the thing is, you're probably going to pay a third party for that, right? You're probably going to have some company out there that's doing this for you, right? They're doing this and then keeping track of where the vulnerabilities lie in your organization. Now, could you write those things yourself? Probably. Is your business, like if you work for an insurance company, does your insurance company want to be in the business of running a bespoke program that does that for you, right? And you might look at that and go, well, I could probably also write something like this and call that API. You can call that API every 6 seconds. So you can do with an open key on this API, you can call it every 6 seconds. So 10 times a minute without any throttling. Do you really want to be in that business? I mean, if you want to be a security engineer and run a company that does that, you should be in that business. But I'll tell you, there's some companies that basically do that, and that's where they make their money. So anyways, I just wanted to mention that because that's how you keep track of that stuff. By the way, we can see that system spinning up right here. Rocky 5 should be pretty. He was getting pretty beat there for a while. Here's Rocky 5. Oh, he's probably back to chilling. Where's he at? We can actually look at just one specific node if we wanted to as well. All right, we're not worried about that though. The question is, so Rocky 5 here. We're back in the Rocky boxes, and we could spin up the CPU. So let's go look at some memory. Can you tell me how much RAM you have? Right, you're just on a Linux box. How much RAM do you have? Well, you have free-m. Well, free by itself would tell you, but that's kind of hard to look at. So free-m is the way that I prefer to look at it in megabytes. You can do a free-g, but that one tends to be, in most modern systems, I mean, we're probably closer to 8 gigs, but that cut off at 7. It was like you've got 7 full gigs, so that's where we're going to go. So that's a thing. But also, you can cat proc meminfo. This is going to the source. But I always tell you guys, you can look at a lot of stuff in the processing directory, in the proc directory. However, everything in here is going to be raw data. It's typically better to look at it from a tool because you're like, well, okay, we've got about 8 gigs of memory and we've got about 6 gigs free. Okay, well, I guess that's useful, but I think it's easier to look at it like this, right? Free-mt will give you a total at the end as well. And one of the things that we're looking, so there's a few things that we're looking for here. Main thing is, do we have free memory? Yes. Do we have too much cached memory? Is there too much over here cached that we could either free up or maybe some application is using more than it should, we can force commits and we can clear it. Can you free all your cache memory? There's also in modern Linux, we always have swap. Linux always wants to swap. It wants to have swap, but we never want to be swapping, because swapping means you're going back to a disk, well, a block device and typically a disk, and that is typically 100 to 1,000 times slower than RAM, right? So you don't want to be doing that. Is that something to think about? So anyway, how much RAM do you have? You can use, if you've got a tool like htop, people like to mention this, dnf install htop, but guys, there's any number of tools that we could use. Htop will show you pretty quickly what kind of memory. There was one yesterday that we were doing. What was that one? Somebody mentioned to me. It's not caches, but there's a name of a tool that shows you a bunch of stuff going on in the system as well. Yeah, so we've got these things here, and I'm not a big fan, so this is just me. I'm going to hit Q real quick. Top is the same way. Not that there's not useful information from these commands, but just as like an admin and engineer, I don't spend a lot of time looking at these. Now, that being said, nothing wrong with sitting around on the screen with top up or whatever if you're kind of monitoring a system. For me, I tend to be looking for more specific things, so I typically want to dig down more than just these things. But I guess at a high level, if you just wanted to check out the health of a system, this is a pretty good little heads-up display. The other thing about this command that I'll mention is you can't give this to your network operations team. You can't give this to management. Management wouldn't even know what to do with a command line, right? They're just Excel monkeys normally. I say that in a semi-derogatory way, but I mean, like, management, they don't have any interest or business being at your command line, right? And the network operations people are typically coming up in tech, so they probably could be at your command line, but this isn't the best use of their time to be individually watching your Linux boxes. Typically, for those kind of people, we feed up something like this, and like I would pull this down and show you guys, like, this is more of what I would show them. This is like a dashboard display. They can see that all the servers are up. They can see that the environment's clean. They can see that the Proxmox system is not under heavy load and we're not over our storage provisioning or any of those kind of things, right? These are the kind of things that I would show other teams, right? I typically wouldn't sit in this kind of screen. Now, could you do it, and should you understand that it's there? Absolutely. I used ATOP a lot back in the day. I don't think we have ATOP or BTOP. Yeah, we'd have to install them. But I liked ATOP because it drove down. I'll show you guys. DNF install ATOP. ATOP had a few parts of it that I really liked. ATOP. Typically, so ATOP shows you across the top what's going on each of the CPUs and stuff. But then what this does is you can actually set this to capture what's going on in the system at whatever resolution you want. I think we used to do every 10 seconds, right? So then we'd have our developers, and I used to have about 200 developer teams that I would work with, and they would, they'd have their Java process start to crash, right? And they would start to crash at like 11 o'clock last night or whatever. If we'd find out if it was in prod, we would find out about it right then because they'd call us out. And if it was dev, we would find out about it the next day and we'd be digging through logs. Well, most system information against the big four, your CPU, your memory, your disk, and your networking, most of that information is gone in real time. Like, if you're not looking at it right then, it's gone. You're not going to get it. Well, with ATOP, you'll get these little slices every 10 seconds. And what I like about it is I could see the CPU. I could see if CPU was hitting an upper threshold and causing problems. I could see if disk, where's my disk? Disk should be over here somewhere. You can see if your disk is hitting high. You can see if your memory was topping out, and you could see if your network was topping out. And you would see down here which process was doing it. So when we talk about like the use methodology of utilization, saturation, and errors on a system, we could see if utilization capped on any of our stuff. We could see if saturation was starting to happen, meaning a process was waiting too long for something to occur, and then from there we could zero in on exactly where the errors were happening and see if the errors were being logged out. So I just thought that this is a way that I would do it when I was like forensically going back through and seeing what was happening on the system. So anyways, that's that. BTOP, I don't know if I've ever used BTOP. I've seen BTOP, I'm sure. Let's see what BTOP looks like. I don't know. I mean, guys, there's a bunch of these, right? There's a whole bunch of them. Oh, that's colorful. So BTOP's going to be like just feeding us all kinds of information. And then I'd let you guys figure out which ones you find the most interesting. HTOP, right, looks like this. BTOP looks like that. And ATOP looks like that. For me, when I was going back through things, I always liked ATOP. Because oh, and by the way, it starts to turn red. Like if CPU was spiking, if memory or disk. And I think disk isn't there because disk isn't really being used. Yeah, there's swap for disk. And we want swap not happening for sure. So anyways, all right. Again, I mostly use that for forensic stuff when I come back and look through it later. But the main question was, could we tell how much RAM we have? Yes. Free-M is the way I'd typically do it. Free-MT will show you a total at the bottom if you need that kind of stuff as well. Now, geez, I could make it bigger. I leave the. By the way, guys, I normally look at a much smaller screen. I mean, I do have thick glasses, but I only leave this bigger like this for when I'm streaming. When I work, I work on much smaller font. I think this is like 16 or something. But I can make it here. Let's make that bigger for a second. Let's see. We'll give BTOP a fair shake. Ugh, I still don't like that. Is that more? Oh God, guys, I can't do colors like that. I'm colorblind, and that looks just bad. Yeah, it's probably just because we're in a screen session and it's so deep down. Yeah. It's I could probably make that look better. I think Putty needs a 24-bit ANSI. That's probably fair. But that's not really. I mean, we don't really need to dig too much into that. It's guys, whatever way looks good for you. I will just tell you one of the things about the reason I don't use these too much is that this is great for one system, but if I need to be monitoring, I monitor thousands of systems, right? In fact, my clusters currently are like 3,200 nodes in Phoenix and 3,200 nodes in Manassas. So I have, I'm not watching any one system. I'm using Grafana and feeding data out for that kind of stuff. But Daytop, I don't know. That's actually funny. So can we tell how much RAM is used? So we talk about the big network, or not networking, but the big admin tasks as we go look at a server is we see if anything's utilized all the way to 100%, if anything's saturated and things are waiting, and then if anything is erroring, right? So we go here and I say, can we see how much RAM is used? Well, that's the same command, right? How much is used right there? How much is free? So we can see that very quickly. You get to a box, you just check very quickly, and then you kind of go about whatever you're doing. Can we see how much swap we have? Same command. We typically, so I'm not running any swap on this box, and there's none available, but that's because this box, there's a reason for that. All of the Rocky servers are stateless node images, so while they have blocked devices, well, they should have blocked devices. These ones have. Why doesn't Rocky 5 have a block device? That's interesting. I don't know why he doesn't have a block device. He should. Maybe we'll go jump to one of the other ones. We'll go to Rocky 2 because I know he does. They've got block devices, but they're not using any of them. Everything here is mounted TempFS, so everything's running in RAM basically on these boxes. That's why I'm not actually using swap for anything, right? I don't have swap mounted here. I don't have any swap available, and if the system went to swap, it would have problems, right? But it doesn't have any swap available to it, so that's that. If I went to one of my normal physical, well, this is still a virtual machine, but if I do a free-M over here, he does have swap available, 8 gigs. However, we do not want to be swapping on these boxes. Should probably go figure out why he's swapping and clean out that. but that's not a big deal right now. All right, so can we see all that? Can you free all the cached memory? So if you had a bunch of cached memory on a box, could you free it? And we used to do this command a lot, echo 3, and then to proc sys vm drop caches. Do you have to do that very often anymore? Not really. All that does is clear your caches and cause your system to write them down. And you can go look up what the echo 1 and echo 2 does. One is, I think one is it drops only committed caches. 2 does something. You can go look it up if you guys are interested in that. But that's a very, very common way that we used to drop system caches. And the main place that I would use this is I'd be working with my developers, and they would have Java processes that would get stuck or would get rebooted or restarted, their Java processes. And I'd have to come in and I'd have to clear the buffer cache, because even though the process was dead, the memory was still being held out there. So that was just a cleanup that I used to do. So that's a way that I used to do that. All right, so let's go look at some file system topics. Can you show all of the used space in the root partition? Yeah, we should be able to do that. So you can use df, right? Df's a fine command. I just think df by itself is like, I would never use it by itself. df-h will give you human readable, and I think that that's much more reasonable to look at. So how much space is used in my home directory? Or in my root directory rather, so slash is root of the file system. And since it's tempfs and it's 8 gigs, we've used 1.4, so we have 6.7 gigs available, right? Now, when you're running tempfs, everything's being stored in the memory of the box. Nothing's being written back to physical disks. This does present a problem. If we were to use up all of the RAM in the server, we could cause it to start going into the killer and start killing processes off, and we would probably render this box unusable. That actually happened in the home lab yesterday. Somebody was using Rocky 1, and they caused it to out of memory killer itself, and then typically the next day I have to go in. We've got an alert that comes up every day. Not an alert, but it messages to our Discord right here in the sandbox. Where's the sandbox at? Here. And it tells us if any of the boxes have rebooted or if they're unreachable. So there was one, yeah, here where auto one, oh, it was auto one. Somebody was in auto one, and I said found auto one in unresponsive state at the console. Out of memory killer had killed processes and made it unstable. Restarted the virtual machine to resolve, because they're stateless nodes. So we just reboot them. You don't troubleshoot stateless nodes. You just reboot them. Now, if they don't come back up, then you troubleshoot the boot process, right, in the build. But that's a different thing. Anyways, okay. We can also do, if we were using the file systems, we could do lsblk-f to see if there were any file systems and what was used inside of them. So this is a server that's, those 3 devices, they're block devices, they are only there on this box so that people can mount them and do testing with them. The systems that are using them, so lsblk-f, this would show how much usage I have of my file system, right? And this is carved up from one disk, xvda, and then he has xfs on them, so we were using xfs at the time. And then these are logical volumes down here for that. We can see all the sizes and all that good stuff. All right. Yeah, to bread, that's my Zen server. Yeah, so my XCPNG, which is a fork. When Zen got bought by Oracle, it was forked to XCPNG, and I've been moving off of that because XCPNG isn't supported. Well, it wasn't ever supported. It's open source, right? But nobody's building, like nobody's updating the Ansible for it anymore. Like it's just not really useful. What's the question? Video somewhere teaching about HashiCorp Vault. So I got my Vault certification back in like 21, but no, I used a dude named Neil. I could go. Hold on. I'll find it, because this is a good question. I don't have one, but I used a guy who was really good. Let me see. YouTube.com. Let's see what's on. Let's go on YouTube real quick here. Hold on. And let's go to Neil. See if I can find this guy's name. I wonder if he's even still working with it, because he's. I think his name is like Cloud Neil. No. His videos are so old on here, they're not even showing up on YouTube. I think his name was like Cloud Neil. Shoot, maybe he pulled him down. Let's go look on Lean Pub. Give me a second here. I'm gonna go see if I can find the book that I bought from him. Oh, there, Neil. It's Ned Bellavance. This guy. So this is the guy that I used his book here when I passed mine, and he was still working on it back then. So Ned Bellavance, that's his name. So go look up. Let me go see if. Hold on. YouTube. This is the book that I use, and his name is Ned in the Cloud. This is the guy that I would go look at for that. And he had a bunch of videos back in the day on, I don't know. Yeah, it looks like he's not really streaming much, but back when I did it, he was putting together. He might even have it in a playlist. Let's see. Vault. Yeah, so he had the vault, and then the book was really good. Now the book's probably a little dated though. Back when I took the cert, but I thought his stuff was pretty good. So if you just want to go through that. That's the way I would do it. All right, let's get our monitoring out of the way. Let's get this out of the way. Yeah, and I have Vault in my home lab. I just need to rebuild it. I've done some talks on Vault, but I don't typically like. So ever since HashiCorp did the business source licensing, I've kind of like stayed more away from their stuff, even though they have some excellent stuff out there still. I mean, Vault is a really great tool. Terraform's a great tool. It's just a lot of companies had to move away from using them because that business source license just kind of causes, for us in our home labs and stuff, we do whatever we want, right? But I mean, as long as the license allows, which business source licensing does. But if you want to like go make money with something, then now you have to start checking to make sure that you're not competing with them. And it's just, some companies didn't want to deal with that, right? Like didn't want to deal with that because you know, you've got the make versus buy versus adopt. And if you adopt and then it brings in like for lack of a better term, like a poison pill, now your organization has these other things it has to adhere to, and it just causes problems. So I don't know, it's something to think about. So can you show all the inodes? So we have in the system, we have two ways that storage is used. There is the actual storage space, which we know of as like gigabytes here. And this system has 6.7 gigabytes available. But there's also inodes. So inodes are addressable locations in memory that the file system has. So let's go look at the df-i. And we're using 17% of the actual storage, but the pointers for storage, we're using about 3%. So if that ratio held true, we would run out of file system space well before we ever even use 20% of this. So in most modern Linux systems, you will never run out of inodes. Now, I say that, and I've been on systems that have run out of inodes. However, it's typically in the storage area networking. So specifically, there's a tool called GPFS, which is the Global Parallel file system from IBM. I've run out of inodes there, and in Lustre, I've run out of inodes. So those are two big, what we call parallel file systems, where you can run out of it, but you also have many nodes using it. And you say, well, why wouldn't they still run out of storage space first? Well, because sometimes in scientific computing, you deal with a lot of very tiny files. And I've actually seen this before where I used to work at a company that did cancer research. And one of the things that would happen there is they had very small pixels, and each pixel got its own file. And you say, wow, that sounds really, really inefficient. It really was for the block size of our storage. It was very inefficient. However, we would still run out of inodes in that kind of system before we ran out of actual space. So, interesting thing. You can look at how to resize file systems. You're typically looking at commands there called tune2fs, and you can tune a file system and you can play with it. Sometimes you just got to get rid of data and purge data off and that kind of stuff. So. But can you show all the inodes? Yes. Do you know what inodes are? They are location pointers to memory where the actual file or pieces of the file exist, right? Can you show all the use space of the directory you're in, right? So you could do a df-h on root, but that just shows me that I'm mounted on root. It doesn't tell me how much of that is used. So let's say I go to df-cd to root, and then I do a df-h on dot. It will still just show me, hey, you're in /root, which is root's home, but you're in this file system. It just shows me like the whole directory that I'm in, right? Or the directory usage on the file system. So what I need to do now is du-sh dot, and it'll show me this directory underneath that file system is 332 kilobytes, right? That's nothing. But we can put some space in there. So let's say we knew we had 6.7 gigs, so we can say dd infile equals dev 0. So we'll just grab a bunch of zeros, and then out file equals root big file. We'll be absolute about it. We'll say block size is equal to 1024K, and count is equal to 5,000. So we're going to make a 5 gig file in here, right? Oops. Count equals. My bad. All right, so that's going to write a 5 gig file. It's going to tell us how fast it did it too, which is nice for knowing how fast storage is running. Then I can do a du-sh dot in this directory, and I'll see that I have about 5 gigs of file in there now. If I were to do a df-h on this directory, I would see that I've used 6.2 gigs, so I've used a lot more. If I did an rm-rf on root big file, I would see that coming back, right? And I would see that shrinking back down because I'm not using that storage anymore. To Brad, what did you say here? I had that before on ext3. If a volume starts quite small and then grows larger later, since it statically allocates a fixed number of inodes during makefs. Yeah. And then xfs is dynamic. That's absolutely true. So I have never seen that on ext3, but that would be true if it was smaller and you kept adding to it. And then most of you guys probably know, but if you don't, in modern Linux systems, you're going to typically see ext4 or xfs nowadays. And ext3 was the first journaled file system for Linux. 1 and 2 didn't have journaling back then. So important things to kind of think about. Okay, so anyways, we're going through all this, but we're just running commands. We're just asking ourselves questions, guys. This is what the Socratic method for Linux is well, Socratic method for anything. Like, how did you come to that conclusion? How did you know that? So when I'm on a box and something's wrong, I'm just constantly like asking questions, like what's going on here? So let's go, we're going to clear the screen up, and let's say that I want to show all the processes that are touching the directory I'm in. This is starting to get into useful things if you're administering a server and like you're trying to unmount an NFS share and remount it somewhere else. Maybe your storage has moved, right? Your backend storage NAS has changed from one server to another. So you're trying to unmount, which is umount, a file system, but maybe you got a bunch of users on the box. So I might do something like this. I might say what directory I'm in. I'm in the root directory, well, root's home directory, and I do an lsof on dot. And it shows me that there's a bunch of processes, in fact, 3 processes that are running in this directory. There's the lsof, which only exists while we're running it. And then we see this bash command, and I say, okay, that PID, that's a long PID, 3454147. But that means somebody is kind of standing in this directory logically. And if you saw an NFS share that had a lot of if you did an LSOF and you saw a lot of processes running in there, you're not going to be able to unmount it without forcing it, and that's a problem. Well, in Linux we call it lazy unmount. Solaris used to be you'd do a umount-f and you'd force it. Nowadays we call it a lazy unmount umount-l. But either way, if I do that, I'm probably going to break. Well, I'm definitely going to break any processes that are reading or writing from that right away. So let's see who's using this bash process. Now, I know I'm standing in there, so if I did an echo $$, that'll tell me my bash process ID. Who wants to bet that it's 3454147? You haven't seen me do this command yet, right? I know that it's me because I'm the only one in there. But if I go over to this box here, and I see that it's, oh, nope, whoever was in there left. Somebody else was in our server a little while ago, right? We have connections for people to get in and do Linux with us. Nobody's in there now, but I was going to say if they were, we could have went and checked what bash shell they had in their bastion going through our environment. It doesn't matter. We could connect and then check it, but that's not that big of a deal. Not that interesting to find that out unless we needed it for some reason. We can. The cool thing about having bastions, if I ever do need to kill a user out, I just kill them right at the bastion and it destroys all their processes all the way through, which is kind of nice. Well, unless they've no-hopped them and then I got to go clean them out of the environment, but. All right. So can I do a long listing of files? Do I know what the permissions are? So I'm in root's home here, and I can do an ls-ld on a directory, and I can see the permissions of the directory that I'm in. So root's home directory has this permission set right here. This is actually the permissions here, right? And then I need to figure out what those are. If I don't know permissions, I need to go spend some time with it. What's a bastion? So a bastion is a way that we allow users to come into a system. They all come in through one node, and then they can fan out to other nodes. So I'll show you guys what the bastion looks like in my home lab. So bang sh. This will go to login here. So this is into my bastion. Now, if you look at my bastion here, you have 10 seconds to make a decision. I'm not going to make a decision. I'm going to see what happens. And those are the courses that you're allowed to go into in the Prolog lab environment. We've got books on 1, 2, and 3 for how those kind of things work. They're all up on the website for free. So now let's go into here. So I'm going to go into one of the boxes. So hold on. If I can type my password right. So I go in. I'm going to say I want to go to the security engineering course, and it's going to pick my backend server for me. So I got the hammer box. I'm the root user. I get root in here. I can see what's going on inside of that server. I need to go check why these don't have disks. But I see that I'm on one of the hammer boxes, and then I could start going through the lab if we were doing lab stuff today for that course. So there's a security engineering course that teaches you how to be in compliance with security requirements, how to build those out into your systems, how to add users. Like, it's a whole course, right? But anyways, that's how bastions work. And this is a jailed user environment that can't get out, right? You can't get out of there. So now when I exit, it zippers me completely out past the bastion back into my original node. So you don't like live in a bastion, you just pass through it, right? All right. So here's the thing, right? We see our directory here. And the directory permissions are read like this. This is octal. And octal is 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2. So you say, what the hell was that, Scott? I don't know what you just said to me. Like, you're like, I don't know what you said, so I'm going to take it as disrespect. Well, 2 to the power of 0 is always 1. So this is the ones column with the X here. This is the 2 to the power of 1, which is itself, which is 2. So that's the right column. And then 2 to the power of 2, which is 4. That's the read column. So you read this as there's read, write, and executable bits set here. So there's a 1, 1, 1. Then there's no bits set here for the group owner, and then there's no bits set for everyone else. So this would be read as 7, 5, 5. That's the way that permission set is run. And you say, Scott, that's too much. I don't know what that means. Okay, here's a quick rundown of it for you. So if we go to our Prolog site, right, here's our little website. I don't know why that's taking a while to come up. And then you go to our Linux automation should have it in this book. Where's the book at? It doesn't really matter which book we go to. Here's Linux admin course, right? It's only supposed to be 92 today in Phoenix. That's kind of nice. We got to 107 a couple days ago. Let's go to worksheet. I think I have it right. I'll find it real quick. Hold on. I'll give you guys a link. The book is all free out on the web. I think I have it at the bottom of... Yeah. And so here's the permission set right here for people that need it. I'll link this to you guys here. Huh. I mean, they could try. They could definitely count how many keystrokes I have, although some of them might run together. But yeah, anyways, so this is what I was talking about. 2 to the power of 0 is the ones column. 2 to the power of 2 is 2 to the power of 1 is the twos column. 2 to the power of 2 is the twos column, right? So owner, group, everyone. That's how that's read. So here's the group, or here's the user owner. He gets 7. Here's the group ownership of the file, or in this case, directory. And that's right here. And then everyone else isn't mentioned because they're everyone it's an exclusive comparison of the user ID and the group ID, right? So that's how that works. So we see all this stuff, right? And again, there's a lot to kind of learn as you're doing this. But can I show a long listing of the file? That command is ls-l. I can also use ls-la, and it'll show me all the hidden files in here. -A always shows you hidden files. Hidden files in Linux, we think we're very clever. We just put a dot in front of the file name, and then the ls command doesn't show you dot by default. If you use a -A flag, it shows all, or what we consider hidden. So all these dot files are hidden files in our system, right? Inside of a root directory, or inside of any home directory, we tend to call these files, we kind of colloquially call them the dot files. So all your dot files in set up your, or some people like to call them environment files, because they set up your environment when you first come into the system, right? That's what they're doing. And then I say, can you create hard links to a file? And yeah, we can do that. So I'm just gonna make dir test, cd to test, and I see that I'm in root test. Okay, now let's touch some file, and then we do an ls-l, and we see some file. It was written with 644 permissions, meaning that it's readable and writable by the root owner. It is readable by the group owner of the group root, and then it's readable by everybody else. Well, if you could get in this directory, you can read it, but you can't get in the directory because of the previous permissions, but that's neither here nor there. So I've got some file, and then I want to link, oh, by the way, here's the number of hard links to the file right here. That's what this is. This is the number of inode pointers to a file. That's what that line, that's what that number 1 is there. So let's test that I'm not lying to you. I'm gonna link my some file right here to some file, we'll link some file 1 to some file, right? Oh, whoops, maybe I'm doing that backwards. To some file 1. Now, if we ls-l in this directory, we see some file and some file 1. So now there's 2 of them, and they're both hard linked twice into the system. Let's do the same thing again and make it 2, and then we do an ls-l, and we see that we keep adding. So what does that mean that they're pointing to the same memory location when I said it's the same inode? If I echo this is some file into some file, right? And then I cat all the files. Well, we don't have to do it like that, but we can just do it like cat some file. He's going to have that in there. But if we cat some file 2, and it's pointing to the same memory location, all 3 of those files are pointing to the same memory location, do you think that this has that value in it? When the system goes to cat and read that file, and then that file's pointing to, all of them are pointing to the same place, is it going to come back with that same line of text? Yeah, it is, right? So that's what it's doing. Ray, how's it going? We are just kind of working through the basics of Linux, right? And I'm kind of calling this like Linux to get the job, because I really think that you need to know these basics if you want to get into administration and engineering of the system, right? So these are kind of our basic. This is also kind of, I call this it's what it is. It's called the Socratic method, where we just ask ourselves questions to make sure we understand. If we don't understand how to create hard links to a file, we go figure it out, right? We make it work. And then once we get it to work, we go, that's how that works. That's, we grok the thing. We understand the thing. So now watch this. I'm going to remove the original file. rm-rf some file. He's gone. And if I do an ls-l, I see only 2 links to it, but that's the file. You saw me throw this value into some file. Then you saw me remove some file. And then the question is, if I cat some file 1, does it still have that value in it? This is an important thing to think about. Or did I delete it because I logically deleted the one that I had put the value into? And the answer is, it's still there. To the memory location. Yeah, this is how, this stuff works. And then you say, well, what happens? So I'll go rm-rf some file 2, and then I'll cat it, because nope, it's still there. So here's the thing when you think about this. Oh, by the way, ls-l in the directory, there's only 1 inode pointer. So what's actually happening inside of a Linux file system as we interact with it through bash is you're kind of like snipping the threads of the pointer to that file. That file, that value with some file located in it still exists out there, even though you removed the pointers to it. This is very important for forensics, for people that want to get into like getting data off of old Linux boxes and stuff. Just because somebody goes through and deletes their whole file system does not mean you can't get all those files back. In fact, there's plenty of tools out there in parted D. Disk. Sorry, I think the tool is called disk part. I haven't used it in a long time. I think it's called disk part. But there are all kinds of tools. Open source. Glances is the tool we were doing the other day. Somebody showed me. Hold on real quick. It's open source disk recovery. Right, there's a bunch of them out there. Test disk and photo rec. That's not what I'm used to seeing. There's also open source. We could do Bento Linux. Bento Linux is a toolkit that is very similar to Kali, but most people know Kali, but most people haven't heard of Bento. But it's typically a digital forensics one. So this has a lot of ways to get data back off of disks. So Bento Linux is the way that you go for that. And where's that at? Bento open box, yeah. And then this is the underlying name of it is Seguri or whatever. So we could look that up too. This is the this is the toolkit for it. Yeah, normally looks like this. They've got a cool little that effect when you look over that's called parallax. That's a pretty cool little effect. I know that from being a shooter. Right, when you do long range shooting, you have to fix your parallax pretty often. So Bento Security Lab. That's interesting. I wonder what their labs look like now. Based on 24043, so they've been updating it. That's good. I wonder when they've last. We should go look and see when they've last updated this guy. Looks like they last updated it about a month ago. So this thing's still getting work. So yeah. So this, but not that we're going that far into it. But some of you, you get into Linux and you want to go do security or you want to go do pen testing. A lot of people want to be red teamers. You can go in here and play with this. This is more of the forensic side, so this is more of like you're getting disks from, maybe something that happened on your system and you're trying to figure out what happened to be able to threat. This isn't quite, I wouldn't quite call this threat hunting. It's kind of after the facts, forensics. You're figuring out what happened on the system, right? The event's already happened and presumably been fixed. But yeah, it looks like they're working on stuff. So if anybody wants that, I'll link that to you guys because that's interesting. All right, so let's get that out of the way. This is again how permissions work. So if you were going through permissions, that kind of stuff, we have a lot of resources out there for you. Also, to plug the Professional Linux Users Group, it's a free place for you guys to go and hang out with other people. And you guys can ask anybody in there. You can hop in the Discord and say, "Hey, does Scott charge you guys after so long?" We've got guys that have been in there for, we're going on 6 years on Discord, and I think 12 years, even before Discord. I think we've been going about 12 years, and I don't charge anybody to just hang out, right? We're doing this stuff to get better at Linux, right? To get a career, hopefully that changes the trajectory of what you're doing, because this can be a really rewarding career for you to go and maintain systems and build systems and. I don't know. I think this stuff's fun. I do it sitting here even when I'm not working. In fact, when I get done with this stream, I do have a bunch of work to do. But all right. So could you create a bunch of hard links to a file? Yes. Could you then identify that there was more and more hard links? Yes. Then it says, can you link a hard link across a file system boundary? This one's interesting. So I see that I have this file. I do an ls-l. I see that he's got one hard link. I do a df-h in my directory, and I see that I've got a different directory called run. Let's go test. Can I touch a file in run test file? Well, it looks like I can. So now the question is, could I hard link? Just go back here to where I was hard linking. And the only file I have in here is some file 1. So where's he at? ln some file 1. And let's try to run that into run some file 1. Now, I don't expect anybody that hasn't tried this before to know if this is going to work or not, but I'm going to tell you this isn't going to work, right? And it says failed to create hard link because it's a cross-device link. So this would be very similar to like there's 2 libraries in my city. And you're in one of the libraries, and in that library, you pick up a little card to go find a book that's in the back of the library. And So the card is giving you an addressable space inside of that library for where you're going to go, or inside your file system if you want to think of it like that. And a hard link is actually a addressable space in that file system, right? But then you pick up a card and it tells you, hey, to find that local disk, or to find that local a file or book that you want, you go to that library. Doesn't make any sense. If it would be like geospatial coordinates. If you're using geospatial coordinates but trying to tell me where something was on Venus, that wouldn't work. You can't use Earth as the map and then go and send me somewhere else, if that kind of makes sense. Well, it's the same thing with cross-linking. It doesn't work like this. Could you soft link it, though? So could you do what we call a symbolic or a soft link? Yes, I can do that. And then I do an ls-l on run some file. And now it just shows me that it is a link back to some file 1, which is some file 1 here. And then if I cat some file 1 here, it's that. If I cat run some file 1, it should say, oh, there's too many levels of symbolic links. All right, so we've got something busted because we're trying to go into a run directory. What I just did, I would normally tell you not to do. Don't go doing that. That's weird. Yeah, don't do that. Then I can unlink, run some file 1, and get rid of it. Oh, unlink. Or you can remove it. It's pretty much the same thing. And then if you ls-l it, it's gone. Right? It doesn't exist anymore. All right. So could you hard link across file system boundary? No, you can't. But I want you to know why. Because a hard link is to a location that's inside. It would be like if I gave you a map to my house, but then it had like, it said, hey, here's a map to Scott's house. Now meet me at Whataburger. And you're like, I don't understand. I've never even been to Whataburger, right? But if you guys have never been to Whataburger, they're pretty good. And then there's arguments online of if they're better than Five Guys and better than, what's that other place people like? I don't know, but it doesn't matter. Whataburger's probably better. But, all right. Where's the file that defines mount points to a system? Well, if you cat etc fstab, or fstab, some people like to call it, this is where those definitions occur. So if I do a df-h on this box, I see that I have 4. It's actually funny. Why is opt labs and home? Home is coming from somewhere else. That's interesting that it's not defined there. But in modern Linux, a lot of people are starting to use these systemd mount files. So I might do something like this. I might do a systemctl and then grep for mount. And here's all the mount files. Because even if something's not in, so let's see, oplab, home is not defined in here, but home is still mounted. See, mounted right here. So I can systemctl cat home.mount, and I can see what's in the mount file for run systemd generator home.mount. And that's how my werewolf system, these boxes inside of my lab, know to mount things, right? That's mounted right there. Home from the werewolf system, and then there. So if I were to do a mount command and grep for home, I would see that home is mounted on werewolf, which is a server inside of my system that shares NFS to my whole environment, right? Not from the fuel lands, but I agree Whataburger is still better as a chain. Yeah, Whataburger's pretty good. I grew up with Whataburger, though, here in the Phoenix area, so I think that it's good. And also, there's a commercial. It's like one of the stupidest, funniest commercials that I've ever seen. And it's like these two buddies sitting across from each other at the table, and there's kind of like this country, voice as the narrator, and he's like, you know that feeling you get, and he's got this deep voice, and he's like, you know that feeling you get when you could have had extra 2 slices of cheese and jalapenos and you didn't get it, but your buddy did? And then it looks over to the buddy and it says, we call that getting out Whataburgered. And the buddy just like takes a bite of this big old Whataburger and he like raises his eyebrow. It's just the funniest thing to me because 1, I had friends that were like that growing up, and 2, it's like we both got the same sandwich, but you out Whataburgered me. So like if the wife ever one-ups me or my friends ever do, I'm like, you out Whataburgered me. It's kind of funny. There's also an old saying called there's an old saying with the first liar never stood a chance. Because, right, the second liar can always tell a bigger story than the first liar. So the first liar never stood a chance. I think it's funny. All right, doesn't matter. Where is the file that defines the mount point? So cat etc fs tab tells us what should be mounting, and cat etc m tab shows you what is mounted. And you're never supposed to edit the mtam file directly. It says it pretty much in every Linux thing ever. But what reads mtab is the mount command. So you can run the mount command and just see what's mounted. And you can see how it's mounted. And more specifically, you'll see what the default options actually expand out into. So if you look in etcfs tab, so if I grep werewolf from etcfs tab, I'll just see that it says for home. Well, home's not even in there. Let's do mount and grep for opt. Right? Opt is mounted from werewolf as it's supposed to be, and it's mounted on the /opt directory as it's supposed to be, right? We see that here. But the defaults and no fail and read write are what was set, but that expanded out to read write, relatime, version 4.2, so we're using 4.2 of NFS, not the older version 3. Here's the sizes for reads and writes. That's the biggest you can go. Name length. So this is the defaults. And you might say, well, if this is the client here, this server is the client. Well, it's a server for our purposes, but it's really just a client to NFS. If he's a client and he grabbed the defaults, where did all of these other values come from? Well, all of those values come from the server. And the way I always explain this to people is you go over to your buddy's house and he tells you, hey, we take our shoes off in this house, right? Well, if you're coming over, you're like the client, you come to somebody's house and they go, we take our shoes off and we put these little, have you ever seen like those little sock slipper things? I've never had a friend make me wear them, but if they did, I would probably have to do it, because if I didn't want to do it, I could just leave. Well, that's how client to server interactions are too. If I say, well, I'll just take all the defaults, then I take all of the values that the server gives me. These are just all the reasonable requests. Now, you can set clients to not accept some of these, but then just know that when you do that, maybe for security reasons, you're no longer going to be able to function the way that you want to. Like, you're not going to be able to mount certain things. And this becomes a thing where I tell you guys sometimes, there's a saying, security is the enemy of productivity. And it's not to say that security is bad, right? I've been doing security my whole career. My PhD is technically on systems engineering, focused on security. I'm a big fan of security. However, does it slow you down in the system? Yes. Does it cause additional hindrances? Yes. Now, are those hindrances worth it compared to the risk of not? Well, that's what an organization's risk appetite starts to talk about. And you start to get into NIST 800-57, which is risk management, right? Risk management framework, RMF. You can Google that if you guys are like, oh, I want to get into risk management. Well, there's all kinds of stuff. NIST RMF, right? Risk management framework. Is that 57 or was I way off? Oh, 37. No, that's not right. What is the risk management framework? If it's 37, my brain's really busted. 53. So I said 57. It's 53. NIST Special Publication 800-53. That's risk-based assessment. And if you're in the government, you have to adhere to these. You have to have one of these for all government projects. I don't get political about this, but for the U.S., this was published under Obama. And whether you like him or don't like him, that's up to you guys. But I'm just telling you, that's the era where NIST 800-53 came out, which was all government systems have to adhere to these security standards, and specifically around risk-based assessments. And if you say, well, Scott, I want to get into the practice of doing formal risk-based assessments, that sounds like something I want to do with a company, there are jobs out there for it. You can do it as a contractor, you could do it with the government, and then you're going to, that kind of stuff. And then you say, well, I want to use those standards, but I don't want to use them with the government. I just want to help implement them in my company. That's perfectly fine as well. That's why these are published. You can go and do. There are fantastic, kind of overly complex, what we call POAMs, Plan of Actions and Milestone documents, that'll help you to implement this in your organization if you want to do that. Not everybody needs to do that. Yeah, Julius, it's NIST 800-53, 100%. Yeah, I said 857. I'm getting my stuff mixed up in my head. Can we do speed writes and reads? Yes, we can write a bunch of blocks out. You guys saw me do a DD earlier. We would just throw a time on the front of it, and then we can loop it over and write. We could do big files and read from it as well. So that's all. I mean, I think that's pretty much. Why do I not have that networking? Right. Oh, maybe because I don't show it as split here when I do it. If anybody's like looking for these notes are all up in the Discord too. If you're like, hey, I want to go review this later. This is, I think this is 400 and something lines of us just doing this stuff that we're working on here. There's also old recordings of it on my YouTube. But if you're looking for it in Discord, you come down here to presentations, and then you scroll up a little bit, and you will find the Socratic Linux. Here's the Socratic Linux method, and then here's all of the stuff, and you can download it, and you can go through all these, and again, this is just to ask myself, do I understand how to find all the CPUs in my system? Do I understand how to check the speed? And you do it now when we're not in the middle of an incident or in the middle of a problem in the system, so that we can do it more effectively later. All right, real quick, I want to show you guys another thing. This is super useful. I bring this up every time I do this. There's a guy named Brendan Gregg, and this is really the standard. If you say, Scott, monitoring Linux systems and building out this stuff is the life for me, I want to know more about it, then you go to Brendan Gregg's site here and you go find out all these different performance tools around Linux systems, right? Here's all these observability tools to see what's going on inside of your Linux box, right? Because again, we want to crawl a system, we want to understand the utilization, saturation, and errors of what's going on with our different components. Because if we can find utilization where it's capped at 100% and we're starting to have saturation, which is wait times, then we can start to find what are our bottlenecks, right? Because where saturation's high, our system is not churning through things correctly, and then we can start to look at how we can make that faster. It's basically the idea of what we call the critical path or the critical chain. If that's the thing that's slowing us down, that's the thing I need to work on next. If I come to this box, I do an uptime and he's chilling on load, I do a free-m and he's capped on memory, I probably don't need to add more CPUs to him. I probably need to figure out what's using his memory. And I can either increase the capacity of memory, or I can go talk to my devs and say, well, hey, how can you do this more efficiently? And this kind of stuff actually comes up when we get into patch cycles and stuff, because we often have to be always patching, right? I made a meme long ago from our old Rick and Morty where it's like, we finished patching today, we celebrate tonight with some patching because tomorrow we patch, right? We just always patch. That comes from the Hunter episode where Jerry's dating the Hunter chick, and she's like an alien. It's kind of funny. But anyways, I think it's really funny. But where I'm going with that is when we're patching systems, there's always new libraries coming in, and it changes the back-end behavior of otherwise stable programs that are built within your company, right? Your company's working on all this stuff, and now when those inefficiencies start to come in, we sometimes it changes the equation on what's happening inside of our system. So anyways, I show you all this to say this guy Brendan Gregg, he's really, I would call him like the expert on this, and really into this tool called eBPF as well, which is system call tracing from systems, right? So there's all kinds of fantastic stuff in here. What is the use method? This is what I was talking about: utilization, saturation, and errors. It's a methodology for analyzing the performance of any system. It directs the construction of a checklist for which server analysis can be done, quickly identifying resource bottlenecks or errors. So I learned this from a Red Hat engineer who I'm pretty sure learned it from Brendan Gregg, right? And then how might you do that? This is actually interesting. I've never went through this, but I might have to link this for you guys. So when you guys hear me talk about that often with the utilization, saturation, and errors, it comes from, at least in spirit, from this, even though I've never actually read this doc myself. Yeah. There's a functional block diagram to see how things are moving. Yeah. Lots of good digging in information for engineering, but also useful just as an admin getting into a system for the first time. All right, so we're on this box. We get over into networking. Could we show all the interfaces of a system? Yep, I can see the interfaces. Yep, I can see them. I can do if config in some systems. It's not there all the time anymore. It shows it a little bit differently. But the one that I tend to like when I'm just like looking quickly at systems is IPBR ADDR. And this is just a quick little rundown of all the IP addresses that are on the interface. So if I were to look at these boxes here real quick, a question I might ask, right? And I always tell you guys, like, I'm a college professor. It'll be 18 years in December that I've been teaching. And I always look at stuff like this, and then I'll tell my students, and I'll tell you guys the same thing. What kind of questions could I come up with from this? Like, what other things might I want you to know from just these things here? And then maybe one of the first things would be, do we have are we using IPv4 or IPv6? And you say, well, I don't even know what those words mean. And I say, okay, that's fair, but we'll get to that. But for people that do know what IPv4 and IPv6 are, based on the types of addresses we have, are we running IPv4 or IPv6 in this network? And then you look at it and you go, well, it's IPv4, right? It's the older version of IP addressing. Okay. Then I say this. I say, well, IPv4 shows up. Are we using dual honed interfaces, or dual stack interfaces, as some people like to call them? Are we running IPv4 and IPv6 together on this network? On this device? No. But if you wanted to see that, let's compare that. This box does have IPv4 and IPv6. So here's my IPv4 address right here, and here's my IPv6, or INET6 as they're calling it here, IPv6 address. And it might look good here, and we could see, yeah, we're using a 128-bit addressing scheme there for IPv6, right? Now, is it routable though? Can I route on it? I do not have routing for IPv6. I have the interface honed for IPv6 packets, but I am not routing IPv6 packets here, which also makes sense because my environment's not set for that. But it's the same thing here. So IPR, we have a bunch of paths and what we call routes in our system that can be determined here, but there's no IPv6 in there. So it makes sense because my routers and my C router device are not designed to handle that. So, okay. So, but the question was, could I show all the interface? So this was a simple question. Then I was just telling you all the weird questions I could ask from it. Could I show all the interfaces? Yes. This box has an ETH0 interface, and then it has a loopback interface. All TCP IP connected devices have a loopback interface. It's for testing, it's for connectivity, and it always has the IP address of home 127.0.0.1. So if you've ever been on a college campus and seen a nerd wearing, I'm a nerd so I can say this, there's no place like 127.0.0.1. There's no place like home. That's what they're saying. And they're saying it like a nerd. So other nerds go, that's funny. And then I think it's funny too. But that's what they're showing here. So can I show all the interfaces? Yes. Can you show the interface that is connected physically on the system? So this one, in this case, I'm going to have to change this command, ETH0. Yeah, can I show that it's connected? ETH tool, ETH0. And I see right at the bottom, link is detected, yes. Why is this important? You might say, why is this important? Well, I started learning this because, or I learned this because I used to work at Lockheed Martin, and I had 5 different data centers in the building that I was in, and I worked in what's called a SCIF, Secure Compartmentalized Information Facility. I had top secret clearance, and I would have to go into these different buildings and go in and actually go touch these physical servers to see if a port was up or not. Like I'd have to go into the back, and I'm colorblind, but typically it'll be a green link light or it'll be a yellow flashing link light, and that's typically how I know them because there'll be a flashing one. And if a link was not detected at all, it would be dark, maybe because that means the switch isn't connected on the other side or something, right? So we used to go in data centers and do that kind of stuff. I guess technically I still do go in data centers sometimes, but not nearly as often. Well, but this is a virtual machine. So this virtual machine, I can't go and take my glasses and look and see if there's actually a connection. Like, so this Rocky system, it sits right here. It exists here inside of this Proxmox cluster right here. Well, I guess I do need Proxmox. So it sits in here. I got to go log in again, I think. I think I just messed that up pretty good. Let's see if I can get in there. Oh, whoops. Oh, do I know my password? There we go. It's fine. So I go to Rocky 2 because I'm on Rocky 2, right? Here's Rocky 2 server. And I come in here to his hardware, and here's his network device, and I hope it's connected. I mean, I guess, I don't know. Can I go look and edit and see? I mean, I see its MAC address here, and I can come over here and validate IP header. I can see that MAC address is D6, D4, D5. Okay, 0F. Yeah, that's it. But how would I know if it was connected or not? Well, I can't go look at it anymore. So where I'm going there, Julius Caesar. So Proxmox is what we call a hypervisor. It is a type 1 hypervisor. So it sits on a physical machine. It's an operating system on a physical machine. And then from there, you can build virtual machines inside of it. So it is a host. It's a Proxmox host, which is a type 1 hypervisor in this case. And then he runs guest operating systems inside of him. These are all the guest operating systems right here. That's what that is. They are all sharing some of his information, some of his CPU and memory right here. They're all sharing it. And then they're using some part of it at any given time. So yeah. So that's a good question though. Yeah, it's a type 1 hypervisor. A type 2 hypervisor looks like this. If I opened Oracle, I don't run Oracle VirtualBox in my environment very much, but if I turned this thing on, which is bright and annoying, and then I started like my GNS3 VM, this would be a type 2 hypervisor because I'm running a Windows system, and then inside of it, I'm standing up a hypervisor as a program, and then that hypervisor is going to share out resources into a virtual machine. That's a type 2 hypervisor. And in the enterprise, we almost exclusively, for production jobs, run type 1 hypervisors. ESXi, Proxmox, other big ones. Those are the two main big ones that I can think of. ESXi kind of ran the market until a few years ago. But then type 2 hypervisors like this are super useful for people who are doing development work. So you're developing and spinning up virtual machines and getting them ready quickly, and then testing your local code, making sure it works. Maybe you're dropping containers in there. That is a type 2 hypervisor, and that's typically how that's used. That's much less common. That's never used in production. Type 2, I've never heard of a type 2 hypervisor being used in production that I know of. Godfrey Paul said, where do we get the Socratic method questions? You come here to our Discord, you go to our presentation section, and you just go up to June 25th of 2024. It's not very far. It's only about 3 pages up, so you don't go very far. We don't post in presentations a lot. And then it's the Socratic method right here. There's also a set of slides that I use with it, and then they just kind of run through, but we're not doing that today. Sometimes I have the slides up. Yeah, VirtualBox is also a type 2 hypervisor. Yep, that's perfect. There's nothing wrong with that, Julius Caesar. I'm not going to tell you guys how you have to do something, but that's that. But yeah, if you need all of these questions with the answers, they're right here. And they should be pretty accurate to what we're doing. So can I show that it's connected? Yes. And this is very important because this is the operating system side seeing that there's a connection out to whatever before we even start testing loopback and that kind of stuff. Okay. So Rocky test is connected to the internet, and then I could start to ping, all the way out. But this also validates other things that we're going to look at in a second here. But can we determine the default route? So I do IPBR ADDR, and I can see the IP addresses that I have. And then I do an IPR or route. Both of them show me the routing table that's set up in my Linux kernel, right? And I say, can I determine the default route? So you wanted to make sure, maybe you go to a system and one of your systems isn't working correctly out of a few of them, and you notice he doesn't have a default gateway, right? Or a default route. Sometimes they're called default routes. Sometimes they're called default gateways. In the Cisco world, we call them gateways of last resort, because again, routers just go like this with packets. If they don't know what to do with them, it's like hot potato, drop it on the floor. But if they do know what to do with it, and our Linux kernels are the same underlying things as what's going on inside of Cisco boxes, by the way. Can you ping? That should be ping. Need to fix that. So anyways, can I tell you the default gateway that traffic is going to go? Yes, it's through the 192.168.200.1 interface. So there we go. Then I say, can you ping the default gateway 3 times? Yeah, I can ping it. I can say ping-c3, because otherwise ping will go forever in Linux. You got to break it. And I say that my default gateway in this environment is 192.168.200.1. And can I ping it 3 times and see traffic back? Yes. Could I ping, if I knew the next gateway, could I ping that? Yes. That is 11.1 in my home lab. And I can ping that guy as well. Okay, cool. Then, what if I wanted to ping, let's ping all the way to Google. And it didn't ping Google, it pinged some weird number, right? That's an IP address. So from that, we know some things just happened. For my system to resolve between Google and that mapping here of this IP address, that there's 2 things that could have happened there. We could have used the local files for the host, and let's just check. grep www.google.com from Etsy hosts. Who wants to bet it's not there? It's not. It's not on my local machine. So what had to have happened then instead was a DNS query. So my system did a DNS query out on port 53 of TCP and UDP. It uses both. And then it got some information back about the IP address of Google. So now we know right here with this test of just pinging Google, something external, we know that my system is resolving DNS. So I have a resolver somewhere. Now, if you said, well, Scott, how do you know? Actually, I think this comes up here in a little bit. We might not even have it in there. How do I know that we resolved? So there's a couple things. How do I know that I didn't resolve it locally? Well, it's not in my Etsy hosts. And then how do I know it went to DNS next? Well, there's a file in Linux, cat etsy nsswitch.conf, and this is actually how we determine the host order. So hosts looked in my files first, which was Etsy hosts, and then it went to DNS. So how did it do DNS? Well, there's 3 commands that we tend to have: dig, ns lookup, and host. Let's see if they're all on this box. DNS, dig. Let's dig for www.google.com. Dig's not there. Let's see, dig. What provides dig? How do we get dig on my system? So DNF install bind utils. I need to add that into the base system. Bind utils. So we'll get bind utils on here, and then we'll do a dig. So with dig, it shows us that we went out and we got a bunch of A records. A records are IPv4 type address records between google.com and some IP addresses, right? And here's the IP addresses that we could have used, and then our system just picked one, probably the top one, and used that. So dig worked. Let's try host. Host also gave us a bunch of information, and it gave us more information specifically around IPv6 addresses if we had the option to use that. We don't in my home lab because we don't have that, but we could have. There we go. So now we also have one other one. So it's ns lookup for www.google.com. And that gives me the server that I used for my ns lookup, which was my internal resolver, 192.168.11.1, and then here's all the answers of, basically going to map with all the other ones of the resolution that I got. Now it's interesting that my system went to 192.168.11.1. If I cat etsy resolve.conf, I see that my system wants to resolve internally first before it tries to resolve out on the popular, this is a Google OpenDNS that anybody can use, 8.8.8.8. And this DNS is always up. You can always ping off of 8.8.8.8. So there you go. All that to say, could we ping the default gateway? Yes, we could. Can you determine the maximum transmission unit of your network with ping? Well, you can determine with IP adder, you can determine the maximum transmission unit of your Ethernet 2 frame, which is 1500 bytes by default. But could you test that? Could you test that if you were to ping 192.168.200.1, which is my local system, my local, that's my gateway, could I test that my maximum transmission unit was actually fixed at 1500. Now this is a question of network engineering. Like this is a question of understanding what's actually happening. And I'm going to add the command here. I'm going to do a -C1, and I'm going to make the size of this 1500. Well, let's go with yeah, we'll go with 1500 bytes to show you that it breaks. And I'm going to set the don't fragment permutation bit to do. So do set the don't fragment bit. I know it's crazy, but now it's going to break. It doesn't work. But hold on a second. I'll change that down just a little bit, because you're like, well, 1500 was the maximum transmission unit, but we're defining the size of the packet, and it's going to get a header from Ethernet 2. So just to prove it, I'm going to drop this down to like 1460. This will work. This will ping and come back. But when I make that a little bigger, I think 1476 is the threshold because the header goes on the front. That's too long. But 1474, watch, that's still too long. Oh, maybe it's 1472. That one did work. So 1472 is the maximum size an IP packet can be to fit down into that Ethernet frame to still be 1500 bytes max as it goes and traverses my network. So I just proved it using the ping command, and I have the commands here for how you could do it. I also pinged Yahoo. If you ping Google, Google doesn't respond to weird frames, but Yahoo does. So you could ping Yahoo if you want with that as well. And this would test end to end that it worked the whole way. And then you've got some traffic back. However, if you do that to Google, it's funny. Google doesn't play. They're like, oh no, they are now. I'm telling you, they used to always block that. When you would do weird stuff to Google, they would never respond. So I think that's funny that they're allowing that now, because that used to always be blocked if you did anything weird within your. Oh, actually, hold on. Let's test, because I might be lying to you. If we can make this, so I'm going to take the don't fragment bit off, and I'm going to set this to like 1600. Yahoo will respond to weird stuff. I don't think Google will. Let's check Google, because that's now a bigger frame. Yeah, Google still doesn't respond. I knew they had that set. Basically, like, I'm mucking around with the type of ping requests I'm sending, and Google just doesn't respond. They're like, I don't play that game. It's like, well, I'm not gonna use that example, but I was gonna go all the way back to the Jungle Book, but that's an old cartoon that none of you would probably remember. That was an old cartoon when I was a kid, right? That was like from the 80s. But yeah, can you identify all your IPv4 and IPv6 networks? Well, in my system, I only have IPv4 networks, so I don't have IPv6. This originally was done when we were first doing these labs. We were out on Killer Coda, which is a free site for any of you guys to use, and we were just in the sandbox doing this stuff. Yeah, so that do frag, that is just a way to set the don't. So you do set the don't fragment bit. We were doing this, so I was explaining this to the guys yesterday a little bit, because we were doing Wireshark. So we have a Wireshark study session where we just kind of sit around and we're trying to get better at learning Wireshark and understanding what's going on. But in my home lab, like, I capture a bunch of this stuff, right? And then I just pause it here, and we go and we look at the the internet protocol, and then there's a flag right here inside of the protocol, and the flags would be set. So don't fragment was set on this TCP packet that was flying around. Well, it's a TCP segment actually, but down in the IP packet, the don't fragment was set. So there's no fragmentation of this allowed, which means that the total size, if we go to the frame, the total size has to be under 1500 bytes. But I see that the total thing is basically nothing. 60 bytes on the wire. This thing's pretty small. Yeah, its full size is pretty small for the full frame. So anyways, we're not getting into, guys, we're not trying to right now to be network engineers, but if you want to get more into network engineering, I will always tell you guys this: your Linux boxes are always going to touch networks professionally, so you should at least have a grasp of what it's doing when it touches that network, right? Mars, you said I'm running Linux Mint on a stack of old 2012 Mac Minis. Nice. Yeah, Linux Mint, I haven't used that one. I haven't used that version. Nothing wrong with it, but I appreciate the Prime. Hopefully this stuff's useful to you. We are going through what's called the Socratic method, where we just ask ourselves questions and say, do I understand what's happening inside the system? And then I'm just kind of I don't know, I guess you'd say pontificating around it, or I'm just expanding on this stuff. All of these answers right here, all of these questions and answers are up in our Discord. They're in a channel called presentations. There's a lot of free stuff, useful stuff in our Discord. I tell you guys, one of the things I think is most useful is the Ansible code section, because me and some of the guys have been writing Ansible in here for years. So I go back and reference stuff like code snippets and stuff. There was a thing the other day I needed to be able to calculate tomorrow's date, so I was like messing with that. There's just always little stuff going on inside of our server. We have study groups. One of the guys is doing Linux from scratch today. So if you guys have never done Linux from scratch, there's a that's coming up today at 3 p.m. Now that's my time. So for you guys, it'll be whatever your time is. But then there's Bash study groups. There's our Wireshark sessions. And then coming up in a few months, so in August, we do our, what is this going to be? This is going to be our 12th year of doing the Professional Linux Users Group officially, and 7 years that we'll be on Discord, because we started Discord right back before COVID started. And here's all the talks that are coming. So if you want to do any of those talks, they're all free. We will have a few hundred. We're going to hopefully get a few thousand people through the server during this time. I love breaking Discord. It's one of my favorite things. But these are all free talks that people can go and listen to. These are all experts from around the industry, people that I know who have been doing this stuff for a long time. Some of these guys speak. Some of these guys are big in the Mang or Fang organizations that you guys know of. Some of these guys, like one of my buddies has a doctorate in economics, and he's a AI. He does AI with his company, and he's an AI kind of like chief engineer for training AI to read his economic papers and stuff. It's kind of funny. Any plans to try to migrate the Discord data for another chat system for backup? Kat, I haven't. I've thought about that a little bit, but I haven't. So, I mean, every time, what happens a lot is the sky starts falling, right? Everybody's worried about, like, you know, the next thing coming, and then, like, age verification, all this other stuff. And then it's not. And then I want to say, like, it doesn't ever come to, like, full fruition. And I think Discord's been trying to navigate it maybe as best they can. If we ever need to switch over to, like, Slack or something, I mean, we could. But no, I haven't, like, really sat down and gotten any plans to pull everything out. I think, I mean, we've got a bot that one of our guys maintains, Fisherman, maintains the bot. And the bot probably could be used to pull a lot of that older stuff off. Yeah, I mean, if we ever really have to evacuate Discord quickly, we'd probably just go to another platform, or we could run Mattermost somewhere as well. But yeah, I'm not like super worried about losing everything like that, Cat, because I'd mostly just be worried because then people wouldn't be able to come in that have been part of the community that have maybe left for a little bit. Hey, wifey. Sorry, wifey's back. I hear her clocking around somewhere up here. Wifey. What are you doing? Oh, she's busy. She can't hear me. On Discord issue, yeah. Well, fair enough. Yeah. Because the Discord, if they do say everybody has to do like face recognition, then we're gonna deal with that. Wifey, I was just seeing what you're up to. Oh, okay. Yeah, you're gonna go. Okay. Well, when I'm done here, I will. I'll come see you. All right. So can you identify all your IPv4 and IPv6 networks? Yeah, we did that. Can you list all your open ports? So this is important, right? I often get asked from people, they're like, hey, how often should I nmap my servers? And I say, well, I mean, you could nmap your servers, I guess. But nmap assumes you don't have privilege on the box. And what I mean by that is, if I wasn't the root server owner, I might scan somebody else's box. But if I own the server, it's kind of like the difference between looking in and or from being inside and looking out, or being on the outside looking in. So nmap is where you want to scan a range of addresses where you don't have privilege. But if you're on the box, you use SSNTULP, you have the escalated privilege of root, and I can see all the ports that are open on the box, right? I can see all the things that are listening for either UDP, right here, here's the UDP, or TCP, right? And here's what's there, here's what's being listened to, and I can go look at that. I can also maybe search down, so I see that this is port 9100, which says it's node exporter, but how might I maybe know that? So maybe I do maybe I do a LSOF on port 9100, and I see that the process that's holding that port open is the command node exporter, and the process ID is 804, and then I see that that is connected from, this is the Prometheus server in my environment that comes and scrapes that, right? And it's funny that it's Rocky Jet Direct. I don't even, that's just whatever. And you say, well, how is that mapped to Jet Direct? Well, you've got a services file, so I can grep 9100 from Etsy services. And if my system thinks that port 9100 is Jet Direct, it'll show up like this. Now I'm going to go fix that because that's super annoying in my system. So I'm going to VI Etsy services. I'm going to /9100. And I'm going to change this Jet Direct right here that I know is not Jet Direct. And I'm going to change this to Node Exporter, right? And then escape. I'm going to do another 9100 and see if that one's there. And if I was going to be using UDP, then I would say Node Exporter. Although it's actually always going to be TCP, but that's fine. Now, if I do that same command from earlier, that's now saying Node Exporter. And then when I do my LSOF here, it now says Node Exporter instead of whatever those dumb ones were that were set in Etsy services. Should you modify your Etsy services directly? Not very often, right? I'm just doing that to show you guys. That's where my system is looking that up in real time. You can also tell your system not to resolve names, which I think is just N. Maybe there's not. Hold on, let's see. Is there a way to not resolve? Yeah, I don't know how to do that in there, but typically I don't want to see this resolved. I want to see that as port 9100. I don't know how to do that directly on there. Let's see I'm not making anything. I wish for the day when all Linux utilities have full word switches, GNU style, so I can see what they mean. Fair. Yeah, fair. So can you prove that your DNS is working? Well, this is important. I'm on this box. I was testing a bunch of stuff. I was checking all the ports and stuff, but now I want to see, can I reach out, right? So obviously I can do IP adder, and I can do IP route, and then I know that I should be able to ping my default gateway at any given time. So, right, so I can ping there, cool. But can I verify that DNS is working? Well, DNS is a resolution of a domain, it's domain name service, so it's mapping human readable names that I can remember to other stuff. So could I ping www.yahoo.com? And the answer is yes. And this is what it actually resolved to. And here's the IP address that it actually pinged to, right? And then I got traffic back from that as an ICMP echo reply for my echo request, right? And I went and sent that over, and then I got some statistics. And maybe I thought that I had like a shaky connection. I might run ping for a little while. I might let this run while we're talking here. And then I might look real quick at the end and see, because there's a bunch of information that's happening. It's telling me, in some ways I'm seeing how many hops there were. I can see the total time coming back in milliseconds, so my round trip. And then when this is all done, I can get kind of an average of that. So maybe I define in my network here. Let's go ahead and let this go for a little longer. I want to know how many times I had a dropped ping. So if ping wasn't working, that's something I want to know, right? Because that's a certain level of instability or unstableness, right? But another one that might be useful to know is I also have the return time, right, for my packets, and I have the average was this. The average, so here's the minimum one, was 15 milliseconds. The average was 22, and then the max was 31, right? And then the deviation, right, the MDev, we could calculate within 42 packets, and this being the average, and then the upper and lower, we can calculate a bell curve, right, a standard deviation, and see if there was a lot of high or low outliers within a set, right? That's what we use standard deviations for, is to see how far you are away from the mean, how many standard deviations you are from the mean. And typically all traffic is going to fall into that bell curve, but if we have high-lying outliers, we could go look at what was happening during that time. We could go, right, we could start to like dig into this like an engineer if we wanted to, right? This is what we do. So we're not taking different paths typically, because time to live is being decremented with each hop, right, of the system. Also, what's going on here? Getting connection requests. Okay. So that's that. We can use host, dig. I showed you guys all this earlier, but can we prove that DNS is working? Yes. Oh, and then this was, we edit to change services port number mapping? Yeah, you guys saw me change edit Etsy services. You guys saw me do that. Other DNS things that are important. We can see what resolvers we're using, Etsy resolve.conf. We can see that. We can see the order that our system resolves names. So cat Etsy nsswitch.conf is, we are looking at hosts, we're looking at files first and then DNS second, right? So files first. So I can override. And you say, Scott, can you prove to me right now that you're overriding that? I say, yeah. Let's do a real quick test. Let's ping www.google.com and we'll grab an IP address right there. Now we're going to ping www.yahoo.com and we're going to get a different IP address. You're going to see that it goes over to Yahoo. Now I'm going to do something weird. I'm going to VI Etsy hosts and I'm going to shift G to the bottom and I'm going to add that IP address there that we know is for Google and I'm going to set that to www.yahoo.com. Do you guys all see that? Okay. Now I'm going to ping www.yahoo.com and I'm going to hit that 142.251, 153, 119. And you might say, well, Scott, that doesn't prove anything. Well, hold on. Now let's look at the website. We'll just grab Google. Well, that for being a Yahoo page sure does have a lot of Google in it. Let's VI our Etsy hosts again real quick. We'll go to the beginning of this line. We're going to comment that out real quick so it's no longer used. Now we're going to curl yahoo.com and look for Google, and there's no Google in there. Now we look for Yahoo, and whoops. Surprised that's not giving me anything back to Yahoo. Let's look at the page real quick. What do they got in there? Oh, too many requests. What? They're blocking me? You guys are blocking me? Shouldn't have too many requests. That's weird. I've never seen them block like that before. But that is kind of funny that we went over some number of requests. You would think that after a little bit of time it would... I'm not doing too much. Not really. Whatever. Screw them. Apparently Yahoo doesn't like me messing around with their systems either. YouTuber said how to completely dump your DNS cache. Yeah, I don't know what they're saying with Edge. I think they're just... I don't know what they're saying with that. Maybe we're doing something that they don't like, because we were hitting it with weird stuff earlier. So maybe there's just some timeout or something like that. Maybe there's too many requests within a certain amount of time. Most of those things clear out in a matter of seconds, but maybe they've got it long running because they don't want people. Because when you're sending stuff like I was doing with different size packets, that is very much to most organizations as though I'm probing their network. They think like, hey, this guy's messing around. Because why else would you send malformed packets, right? Systems by default follow the rules, and then I'm mucking around and sending different size packets to you. They know that you're using some type of traffic tool. I was just using ping and doing different weird stuff, but yeah, I don't know what they mean by edge there, but they could mean edge case of too many requests. But either way, they're not responding to me right now, so that's kind of funny. How to completely dump your DNS cache? I'd have to look that up. I don't do that very often, but you can dump DNS caches out of your systems. I don't know how to do that right off. I'd have to, as with everything that I don't memorize, I just have to go look it up real quick. DNS cache in Linux, right? I don't know how to do it right off, but there should be something. Maybe resolve CTL. Yeah, because you do typically have. Let's just do this. No. So apparently we don't have that running. And we could try this. Yeah, I don't even know if I've ever seen that. System CTL or System D. Yeah, there's no command there for me. Yeah, no commands there for me. So, yeah, I don't even know. And then there's the name service cache daemon, but I don't really use that either. I don't think that's even on here. Nope, not even on here. So, yeah, I'd have to look that up because I don't really use that. And Red Hat probably has this. Yeah, you got to sign in. Although I do have a Red Hat account, but I'm not gonna log in there right now. I have a Red Hat account for one of my things. So, yeah, yeah. All right, can we connect to another server and test it for an open port? Yeah, we can. So we could use Telnet if we have it. Most servers aren't going to have Telnet nowadays. And you don't want to use Telnet for any actual traffic. You just use it to test a port. Normally, you're going to have NC. So I can NC and just see if device is open for, let's just say that I wanted to connect to, maybe check to see if port 53 is responding on .1. And then I use port 53 maybe. And it'll tell me, yep, it connected because that thing is responding on DNS, right? I could also use maybe for my Werewolf server, which is 25, is port 22, which is SSH open. Yes. Oh, 200, man, I'm dumb. 200.25 is my thing. And then it was connected. Now, you can take the VZ off and you can see the header. This is actually why we talk about security through obscurity. That is just going to sit there for a while because now it's waiting for an OpenSSH establishment of communication. But this is one of the reasons we talk about security through obscurity doesn't really matter. If you say, well, I don't want to use port 22 because everybody knows port 22 is SSH. I'm going to use port 10022, so 10,022. I'm going to use that port for my SSH and nobody will ever find it. Well, that's fine, but then when somebody scans your network, especially externally, and then they hit port 10,022 and try to connect to it, it tells them what it is. This Netcat isn't trying to connect as SSH and being told it's SSH. Netcat is just trying to connect to that port. Doesn't matter what's on that port. And that port sent back header information that says it's an OpenSSH server. Meaning, if they were going to then, now they have mapped 10022, 10,022 on your system to that. Now they're going to start scanning whatever their attacks are for SSH. They're going to run their Metasploit and do their script kiddie stuff. In my home lab, some of you guys have seen this before, we're constantly getting hammered, right? We're in the home lab, we're constantly being hammered. These are all the people that have tried to log in the last 6 hours into my home lab right here. Most of them are from they are different, so they're getting locked out, so they're switching their IP addresses, but they're trying to log in as root on my system. Why do they try to log in as root? Some of you guys know this. It's because in modern Linux systems, root never locks. So they're going through, I'm getting massive amounts of them. These are all different IP addresses, so this is probably a botnet trying to get into my system on root. Well, here's the thing. The first thing you do if you expose anything out is you harden it to a certain level, and one of those levels for SSHD is you turn off root access. Root can't log into my bastion. You have to be a user. So now you can't just guess root and then try to log in forever, right? But then we have other things. There's fail to ban going on. So fail to ban is logging these out. We could watch that in real time if we wanted. We could say watch fail to ban. Let's do this. Right, so here's the status for fail to ban. Should be this one. Right, so we can watch that. We can just sit here while we're talking and watch nodes actually go, and actually they'll pop up here in real time as well. Right here at the top. So we would see new ones. So 727 was the last one that failed to come in. And oh man, they're using some weird ones. Look, admin gpon. I don't even know what admin gpon is, but that's probably some default password that exists out there, which by the way is one of the reasons we immediately changed default passwords for pretty much all of our standards. Administrator would never use that in a Linux box. Admin could be there on certain services. Ubuntu's often there on Raspbian and some of these other ones. They also try Pi often. admin DB. So if I had some weird database that had admin DB set up, there's a bunch of them. Minecraft, Student2, Twan, David, Postgres, right? They're trying default passwords up and down my system, right? And this stuff doesn't bug me very much because this is what people do. And I've got a mapping of all of these IP addresses to geolocations as well. I haven't shown that on stream in a while, but I do have that because I think this stuff's hilarious. But this is why we build bastions before we connect things out to the web, right? So, all right. And I have how to build bastions and stuff all over the place, so you guys can go find that if you want. Can you connect to another server and show debug for multiple levels? We'll leave this running here. That thing can just sit there in the background. But can I connect to another server and then see how that connection tried to connect? So I'll SSH over to Rocky 5 maybe, and it says, do you want to connect? And then I don't have the password, so I couldn't connect. But what happened when I did that SSH over? I'm going to add 3 V's, and look at all this debug information that comes out. It tells me that my system tried to look it up, tried to look up that other server, tried to figure out where he was. Where's my V's here? Okay. It says that, so I connected over to him, and I got a header back. I read some config. Oh, actually, this is my local machine still. And then I looked in my etc ssh config for my client configuration. So if there's any important mappings that were going to happen, we include this configuration for Red Hat. We actually include any configuration that's in here, ssh_config.d with a .conf on the end. And then there's some things that are happening. This is how we harden boxes too. We'll put any specific MAC and hashes that they won't run in here. Here's the values that are okay, and then we negotiate with the other machine to figure out, that's going to happen here in a second, but this is all still client configuration. We get down here and we resolve Rocky 5. How do we do that? Well, we know who it is because he's in the known host file, and then we find his MAC or his IP address here inside of our etc host file. We directly connect it over. Now, once we establish a connection, we look internally to see if we have any of these files. None of these files exist. None of these files that we might have used for keys exist. So then we come down here, and we can't hand it any files. We're trying to authenticate as root. And we're going to attempt keys if we had them, but none of those keys work. And then we come down, and it's going to ask us for a password. It says the remaining preferred password is the authentication protocol. You guys can dig into all that if you really want to. But now I'm sitting at a password prompt. I'm going to hit Control-C, and then it's gonna stop working. But yeah, we tried to authenticate through everything that we had, and none of those things even existed. We knew they didn't exist because up here on the check, they came back with -1, which means that it didn't exist. Saint Device, login only through SSH keys and only locally is what's best. Sure. That's actually a good method for internal systems. I allow my Bastion to be connected to remotely, so I'm actually okay with people getting into my environment from the outside. So, and I allow that for people that don't know. If you come into our Discord and you go to the Prolog Lab environment, and you just give a key. You always give a public key. You never show anybody your private key, and you add that key in. It'll add it successfully into our server, and then you use your private version of your key, and you get access. That's how you get into our environment. It's pinned right here as the pinned messages. It shows you how to use the tool, and then it shows you, you can add your key, and you can also remove key. So the bot helps you out there. The bot also talks a lot of trash to me. So if you ever use my name Scott in the server, you'll see what we mean by that. But that's that. Can we verify that nothing is blocking to Google? Yeah, we can just curl Google. And then we see, are we actually on a page that's probably from Google? Yeah, there's a bunch of Google information in there, so that makes sense. So again, as we do this stuff, as we try to learn Linux and get into it, the Socratic Linux method is just asking yourselves questions, and we barely got about a third of the way through this. I have this recorded, and there's just, it took me, I think when I first did it, it took probably close to 12 hours to just walk through all this information. But it's just like, do we understand what we're looking at inside of a Linux system enough to go do this stuff professionally, right? And I think that all of you guys can do this, especially if you're doing it as a hobbyist now. I do think that you can get in here and get good enough at this stuff to do it at a level that a company wants to wants to hire you for. So I'm not going to go through all of them today. I think that that's a pretty good start, and I think that that gives you guys a pretty good look at the basics of the system and gives you a place to go. If you're like, hey, I want to get more involved with Linux and I want to learn this stuff more, again, we have a bunch of free stuff in Discord that you guys can go do. So we got a bunch of events. Linux from Scratch is starting in, I don't know, that's like 5 hours from now, but it'll show it in your time. And then they're going in and they're doing Linux from Scratch, which is a free ebook that shows you how to build a Linux kernel, how to get your compiler set up and all that kind of stuff if you've never done that. Now, I give that with the caveat, in professional Linux, we very rarely do that because we're almost always using something that's supported by a vendor. But it's one of those, your mileage may vary. You may find something really interesting in there and go, you know what, I want to go work on the Linux kernel. Well, it's open source. You can go get involved with those communities right now if you wanted to. So there's a lot of stuff available to you guys. Bash study group is every Saturday. I know they were down there working on that yesterday. There's 136 people saying they're coming, but I don't know. I've seen anywhere between, I think there were 3 or 4 yesterday, but sometimes there's up to like 20 or 25 people. So you just go in there and hang out, and if you don't want to talk, you don't have to. You just kind of hang out with the group and do whatever. Wireshark study sessions, that's for people that want to learn that tool, Wireshark, a little better. Been doing that as well. So, okay. I'll probably hop off of here, but I definitely appreciate you guys hanging out. Best way to get a hold of me is on Discord, so if you guys have specific questions. I know people are going through some of those admin courses and engineering courses. People do those on their own time, even though we're not officially running through one of them right now. The reason you go through those courses, you say, Scott, why would I want to go through one of your courses? Well, one, I think you'll learn a lot of Linux, and I think that's valuable. And two, we do this. If you guys didn't know, so this is Shane Dugas. He's only people that want to be shown will be shown on here, but he is, what's going on here? Let's wait for the certificate to come up. Sometimes our caching kind of has a little bit of a problem. Hold on, give it a second. Should have everything connected still. Yeah, here we go. And then this was him going through the ProLug Linux Security Engineering course back last year, almost a year ago now exactly. And then he's got his cool little hash where he can show this. He can put this anywhere, and when people go and check, it'll come up as a as he went through the course. And this is only there's I mean, I guess people could try to fake these if they wanted to, but you couldn't fake them inside of our server for people to validate. And then there's a few different people that show up here. Hold on. Trevor's one of them. And again, they had to opt in. If they didn't want to be shown up here, they wouldn't be. But they do have the option to have this, a set hash directly for them. And then it's funny, they were making fun of me the other day because I show up on here. And it's like I'm doing this, like I'm patting myself on the back, which I think is hilarious. But this is from when I originally ran the courses, right? And then we were doing that. So those are all out there for you guys to play with and get, if you're like, hey, I just need something to put on a resume. Well, that's what you do. Enjoy my Sunday. Yeah. Hopefully this stuff's useful to you guys. I'm going to drop off. I'm going to go let's find somebody to raid here.